Okay, this is 223. So we're going to talk about activity series. Remember early on when I asked you what a chemical reaction was, and you said you mix two things together, they react, they go boom, or they go whoosh, or they go bubble, bubble, bubble. And I said, well, do any two chemicals that you mix together necessarily react? And you all went, well, no. You know, because you know that if I stick a chunk of aluminum in a glass of cold water, nothing's going to happen. You've done this before. If I mix some baking soda and salt, nothing happens. It's very boring. We can predict what will react using an activity series. So this is just a list of chemicals in order of reactivity, and it's organized so that the most reactive things are at the top, and things get less reactive as you go down the list. Now, I guess we'll finish the slide and then we'll start some examples. So, there is an activity series in your book on page 266, if you would be so kind as to look at that. We can actually look at two things that we're going to put together, and we can say, will they react? And we can answer that question. We can say, yes, this will react, or no, it won't. And activity decreases. So the most active stuff is at the top. So top is most active or most reactive. Bottom stuff is pretty unreactive. And if you look in your book, you'll notice that at the bottom of the first column, you've got silver, gold, and platinum. Those are the things that we actually use in the body because they're unreactive enough. So I think I told you guys about the heart of gold. The father of somebody I worked with had a stent in his aorta, and they make it with a mesh made out of gold. So the joke was Larry had a heart of gold because they had taken this sort of wire mesh made of gold, and they shove it down in the artery to stabilize it. Because gold won't react. It's unreactive. So it's platinum. That's why if somebody gets a hip replacement, now they're using some other polymer kind of product, but those used to always be either platinum or titanium. So they talk about titanium joints. Big thing to notice. There are two columns. One column is metals. One column is halogens. Never the two shall meet. Okay? They absolutely do not meet. And I'm going to select, copy. We're going to go to the next page with this. So let's think about that. We had talked about a reaction in which NH4Cl encounters bromine, Br2. And we had talked about figuring out which one would replace which. So in this case, which one is the bromine potentially going to replace? The ammonia or the chloride? Chloride, because they're both halogens. That's all we're saying with these two lists. This side, halogens. They can replace one another. This first table, which is a lot bigger, those are your metals. Those can replace one another. Okay? That's not a hard concept. I think you guys have that. Let's actually look at that first column. So it lists all those metals in order, but you'll notice that there are also some little subdivisions here. So we have a line there, and a line there, and a line there. And within each of those subdivisions, it gives you some additional information. So in that first box, lithium, rubidium, potassium, barium, strontium, calcium, and sodium. It says, react with cold water and acids replacing hydrogen. React with oxygen and form oxides. So, if I take a chunk of lithium and I add it to water, and I tell you that this is occurring at 20 degrees. Will it react? How many of you say yes? Thumbs up. Will a reaction occur? Yeah. So what's the lithium going to replace in water? If you got two choices. How many of you know finger spelling, sign language? A, B, C, D? No? Okay. This is an L. This is an O. That one's pretty easy. This is an H. So will the lithium replace the H or the O? Yeah. And this looks like cool chemistry gang signs. Okay, it's going to replace, if it will in fact react, and you all say it will, it's going to replace the hydrogen. So what would our products be? Jot it down on a piece of paper. Commit your answer to paper at least, so you can prove later that you were right. Well, I'll give you one clue. Whenever we have something occur where hydrogen is replaced, it starts to bubble. You know what the bubbles are? Hydrogen gas. So one of our products is going to be H2, gaseous H2. The other one is going to be, how many of you have lithium oxide written down? Awesome! Yeah. Now, the key is when you write down that lithium oxide is going to be a product, make sure you have the right formula. So it's Li2O. Make sure your formulas are correct. Okay, so let's look at the next box. That would be from magnesium down to cadmium. So, what if I tell you that I take a chunk of aluminum and I add it to water at 105 degrees Celsius? Will it react? Why? Give me the evidence. Yes, because it states that these metals will react with steam, not with cold water, but with steam.
Excuse the interruption.
And there they go. So, you all claim that this will react, and your evidence is found in the statement right here that these things react with steam. So, yes, these react with steam. Yes, they will react with water at 105. What would they replace? Hydrogen. Metals tend to replace hydrogen. So again, we're going to get bubbles, and we're going to get what? Aluminum oxide. Remember to write the formula correctly. So that's Al2O3. Okay? Don't forget that aluminum's got a +3 charge. I know a few of you had some problems with that on the homework. If you did those problems where you had to write and balance and everything was already balanced, you have a problem. I can show you what it is. Okay, pretty easy, right? Let's look at lead. So if I put lead together with water at 120 degrees Celsius, will any reaction occur? Why not? Where's your evidence? Yep, does not react with water. So what we would write here is just NR. Circle it, no reaction. No reaction occurs. Okay. These are all good. Now let's get into really using the series in its more fundamental way. So we'll cut these. When we say that something will replace something if it is more active, I want you to think back to the dance metaphors, okay? And getting dumped for somebody else in the middle of the dance. That heartbreaking single replacement reaction. Why does a single replacement reaction occur? So let's say you have two choices of dates. And date number 1, your current partner of choice, is a bit of a slug. Like, what do you want to do? I just want to sit on the couch. Do you want to go out and go sledding? No. You want to go to the mall? No. You want to go visit people? No. Do you want to put a movie in? No. Do you want to make popcorn? No. This person is really pretty uninteresting. They're perfectly content to sit on the couch and stare at the wall, and they're pretty boring. So this is your first option for a date. Woo-hoo! Your other option for a date says, hey, I've got an idea. We could bake some cookies, and then we can go visit people, and let's go see a movie. Do you want to go see some music? Hey, let's go for a hike. It's really gorgeous out. Oh, did you know that there's this like really pretty crescent moon tonight? Let's go out and take pictures of it. Let's go do things. I like to do things. What do you like to do? Let's go do stuff together. Okay, aside from if you're really exhausted and date number 1 might sound pretty good right now, date number 2 in the long run is a lot more fun. You don't really want to sit on the couch and watch paint dry for very long, you know? So the date that is more active replaces the couch potato. Nobody wants to date a spud, okay? Beware if you are the spud. Somebody could come along who has plans and ambitions. You know, boom. So let's look at that in terms of some chemicals. If we've got that compound, what is that compound? Which copper? Copper 2 chloride. So if we've got copper 2 chloride, and we would have this in aqueous solution typically, and we stick a piece of zinc metal in there, will a reaction occur? So what we have to do is locate copper down there and zinc up there. Who's the couch potato? Copper. Copper's been sitting on the couch since last month. Hasn't gotten up except to pee. Won't even make popcorn. Man, Copper's still wearing the same pajamas it was wearing last month. This is really not your dream date. Zinc, on the other hand, wants to go places and do things. Have fun. So the more active thing replaces the less active. So if we were going to predict products, what would our products be from this reaction? Okay, one of our products is copper. Chunks of copper metal. What's our other product? Zinc chloride. Now zinc typically only forms zinc 2, so we get ZnCl2. Okay? And that reaction will run. What if we do... What if we take... well, here's a good one. Al2O3, which is aluminum oxide, and we mix it with iron. Will it run? Which one is more active? Find them on the list. Aluminum is more active. Guess what? Oxygen's already got its dream date. It's not trading down for a couch potato. No reaction. No reaction occurs. Now this is, do you remember the thermite reaction we talked about? Welding in the Old West on the rails? That was iron oxide, probably FeO, who knows? I don't know which iron oxide, plus aluminum, and we got it to form aluminum oxide and pure iron. We can't reverse that reaction. So that's the other thing, is these activity series are useful also for predicting whether or not a reaction is reversible. So two things have to be fairly similar in reactivity for a reaction to be reversible, and you can also imagine that things such as temperature and conditions like that change that affect reversibility. That's beyond what we do here, but as a like, hey, think about that, that's down the road. Okay, so this of course does react, and we get Al2O3 and iron. That's a formula equation I'm not going to balance right now. Okay, so pretty comfortable that you could do that? Let's do a couple with the halogens, and I'm going to hand you a practice sheet, and you're going to practice. So let's get rid of our metals. Now, you'll notice that the halogens are a short list. There are only 4 of them. So what if we take a solution, aqueous solution of NaCl, and we add to it, we bubble through it, fluorine gas? Will a reaction occur? So what we have to do is find fluorine and chlorine. There's fluorine, there's chlorine. It's a short list. Which one's more active? Fluorine. Will a reaction occur? What are your products? Okay, I have NaF. I forgot to switch colors. Hopefully you're all okay with that. And what? Chlorine gas. Be careful here, because that chlorine is diatomic. It's on its own. The 2 does not follow the fluorine. Okay? That's one of the most common mistakes that I see, is people go, but fluorine's diatomic, it always has to have a 2. No, 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 no. Only when it's on its own. So don't do that. That's a common pitfall. Okay, let's do another one with the halogens, and then I'll hand you your practice sheets. Calcium bromide. And we add iodine. Will a reaction occur? Iodine is the very bottom of the activity series for halogens. Basically, iodine will never replace anything. Iodine is the couch potato-iest of couch potatoes. So, no. And actually, it's sort of yellowish in its pure state. But what we see is typically an iodine compound. So, it was still a good joke. Or at least not a terrible joke. I've heard worse. Okay. Pretty good with this? It's not a real tough concept. It's just getting used to using it. So you got the activity series in your book. I'm going to hand you the sheet, and